Hi friends, in the previous video I talked about the Otto cycle and diesel cycle, and in this video I am going to explain about the differences between the two-stroke and four-stroke engines. Even though the present generation automobiles are fitted with the four-stroke engines, but I felt it is essential to know the basics about the two-stroke engine and the differences between the two-stroke engine and the four-stroke engine. First of all, what is meant by a stroke? Stroke is nothing but if a piston travels from one end to the other end, it is called one stroke. In this case, the piston is traveling as per the arrow from top center to the bottommost center. This is one stroke. And again, the piston travels from bottom to top. It is called one more stroke. So if an engine completes a complete cycle, a cycle is the sequence of four operations, that is suction of the fresh air or air fuel mixture, then compression of the air or air fuel mixture, then generation of power, that is combustion, then the evacuation, that is exhaust of the burnt gases. If any engine completes all these four operations in two strokes of a piston, it is called the two-stroke engine. If an engine completes all these four operations in four strokes of a piston, it is called the four-stroke engine. Another important point, in two-stroke engine, there will be one power stroke for every one revolution of the crankshaft, because for every one stroke of the piston, crankshaft rotates 180 degrees or half revolution. So for two strokes, half revolution plus half revolution, one revolution. In case of four-stroke engine, four strokes into four halves, that is two revolutions of the crankshaft. So for every two revolutions of the crankshaft, there will be one power stroke in case of the four-stroke engine. Okay. Now let us start with the two-stroke. Observe this figure and see the various parts of the two-stroke engine. This figure represents the two-stroke engine. This is the cylinder. Inside there is a piston and connecting rod and crankshaft. You can see this engine, it is having ports. The bottom one is the inlet port and top one is the exhaust port, and there is another port inside the engine which is called the transfer port. So you can see this. Now what happens in these two strokes? Let us observe. Observe this figure. The piston is moving from bottom to top. If it is in the bottom, means the piston will be somewhere else, okay, here, and it's moving up. When it is moving up, the air is whatever the air fuel. This figure represents the petrol engine because the spark plug is available here. As an example, I am explaining a petrol engine, and the two-stroke engines are available in diesel engine also. So what happens when the piston is moving up, whatever the earlier air fuel mixture available inside the cylinder is being compressed. So when the pistons traveling upwards from bottom to top, this exhaust valve is closed. Inlet valve, however, it is below the piston. So దీంట్లో whatever the gases available inside the cylinder cannot escape. So those gases are compressed inside the cylinder, which means the compression process is being taken place. Same time, what is happening below the piston? Because from here, when the piston keep moving upwards, a kind of suction is created in the crankcase. Further, there will be a pressure difference between the atmosphere pressure, that is 14.5 psi, and inside there will be almost less pressure or the vacuum. Because of the pressure difference, fresh air fuel mixture enters through this inlet port into the crankcase, which is called a suction activity. So suction is being taken place. Simultaneously, compressor also is being taken place. Suction and compression both are happening when the piston is moving from bottom to top from this position onwards. Okay. Simultaneously, two operations have completed here. Next, at the end of the compression stroke, spark is generated to the spark plug and combustion taken place, gases expands. When the gases expands like this, the pressure thrust acts on the piston crown and piston is pushed down from here. That means the piston start traveling from here to here. Once the piston crown reaches this place, then these exhaust ports start opening. Already gases are expanded, and because of the velocity due to the expansion of gases, the exhaust gases passes through this port. The piston comes down further, and whatever the already available fresh air fuel mixture is being pushed, and simultaneously a transfer port at the other end is opened. The piston travels below this line, causing pushing of this already available fresh air fuel mixture and passing through this exhaust port inside the cylinder. So when this fresh air fuel is entered into the cylinder, partially it pushes the leftover burnt gases out of the cylinder. In that process, some fresh air fuel mixture is wasted or evacuated through the burnt gases. This is kind of small loss. In this stroke, the power occurred and also the exhaust also occurred here. Here, compression and suction simultaneously. Here, power and exhaust simultaneously happens here. So within the two strokes of the pistons, all the four operations, suction, compression, power and exhaust are completed. So that's why it is called the two-stroke engine. You can see this animation. This is the inlet port. Air and fuel mixture is entered here when the piston is moving top. Okay. And passing through this transfer port, compressed, then power, then gases expansion, burnt gases going out, and this green color fresh air fuel is pushing the burnt gases. For every two strokes, one power stroke happens in the two-stroke engine. For every one revolution of the crankshaft, one power stroke occurs here. Now let us move to the engine. It's very simple. All the four strokes, each stroke, one operation is completed in this model engine. Observe this figure. Suction of the fresh air fuel mixture happens when the piston travels from TDC to BDC. The volume is increased, suction is created, inlet valve is opened, the fresh air charge is entered inside because of the vacuum and the pressure difference between the atmosphere and inside the cylinder. Then by the end of the suction stroke, suction valve closes, exhaust valve is already closed. The piston starts moving upwards. Both valves are closed. Whatever the air fuel mixture entered inside the cylinder cannot escape. So the same is compressed here. When the piston reaches at the end of the compression stroke, a spark is generated in the spark plug. Because of that one, combustion takes place inside or the compressed air fuel mixture. Because of the compression, gases expands and that thrust acts on the piston top and the piston is pushed downwards. So when the piston is pushed downwards, again gases completely expands. By the time piston reaches the downwards, the inlet valve kept closed. Here both the valves are closed during the power stroke also. Here inlet valve is kept closed, whereas the exhaust valve opens. At that time, piston starts moving from BTC to TDC, evacuating the burnt gases out of the cylinder. Suction or intake, inlet valve open, piston travels from top to bottom and fresh air fuel mixture is entered. Then compression, both valves closed, piston travels top. Whatever the air fuel mixture entered inside the cylinder is compressed. Then compressed mixture is ignited to the spark through the spark. Combustion takes place, power is generated, piston is pushed down, the power stroke occurs. Then again here the exhaust valve is open, inlet valve is closed, and the burnt gases are swept out of the cylinder. This is how the four-stroke engine works. This blue color is the entry of fresh air fuel mixture. See this? Inlet valve open, entering, being compressed, spark is ignited, power is generated, so burnt gases are being pushed out. Here for every 4 strokes of the piston or 2 revolutions of the crankshaft, 1 power stroke occurs in this case. You have already observed the differences between the 2-stroke and 4-stroke. However, we'll see once again. All 4 operations, that is suction, compression, power and exhaust, are done in 2 strokes of the piston in case of 2-stroke engine. In case of 4-stroke engine, all these 4 operations are completed in the 4 strokes of the piston. In case of 2-stroke engine, ports are provided in the cylinder to allow the fresh air fuel mixture inside and to evacuate the exhaust gases. Whereas in case of 4-stroke, valves are provided for fresh air and also for the burnt gases. In case of 2-stroke, ports opening and closing is done through the movement of the piston inside the cylinder. Whereas in case of 4-stroke, there is a separate valve operating mechanism is provided in the engine. That is having a camshaft, push rods, rocker arms, etc. etc. Whereas no such mechanism is necessary in case of 2-stroke engine. Again, in case of 2-stroke engine, 1 power stroke for every 1 revolution of the crankshaft. In case of 4-stroke, 1 power stroke for every 2 revolutions of the crankshaft. 2-stroke engines are being small, they are mostly air-cooled engines, whereas 4-stroke engines are mostly liquid-cooled engines. In 2-stroke engine, piston and liner lubrication is done through the oil splash or mixing the oil with fuel with lubricant. We have seen the old scooters and some mopeds, when they are filling the petrol, they mix the lube oil, engine oil. So, if in case of 4-stroke engine, separate oil pump is provided for the lubrication. In case of 2-stroke engine, part of fresh air, we have seen in the figure, part of fresh air or air fuel mixture goes along with the exhaust gases because of the design of the engine is like that. So it goes waste along with the exhaust gases. Hence, the efficiency is comparatively low. And in case of 4-stroke engines, there is no such wastage of the fuel or fuel mixture because all the 4 operations are independent. In case of 2-stroke, more pollution happens due to the partial lube oil burning because the oil goes along with the petrol. So lube oil burns, that's why blue smoke or white smoke comes. And also unburnt fuel is released, unburnt fuel is let out along with the exhaust gases. So like that, more pollution takes place in case of 2-stroke engines, and in case of 4-stroke engines, less pollution comparatively. 2-stroke engines are comparatively less efficient, whereas the 4-stroke engines are more efficient. That's why all the major machines, even the motorcycles also nowadays, all the 4-stroke engines only coming out. 2-stroke engines, in fact, are being phased out almost. Just for the sake of knowledge, I am just giving 2 more types of engines, internal combustion engines. This is called the rotary vehicle engine, which was used in the race cars in olden days. There is a cam mounted on an eccentric gear, and this cam is placed inside a housing, oval housing, and there will be ports, inlet port, exhaust port. Opposite side there will be spark plugs. What happens when this cam is moving like this? Because of the difference of the volume, Because of the eccentricity design, the difference of volume at each phase will be there. Because of the difference in the volume, here because of the edges piping action and the suction creation, fresh air fuel mixture enters here, and as the rotation continues, this volume is decreasing like this. So this much quantity is being compressed here to this less volume. You can see compression from here it is being going, volume is reducing. So here full compression has taken place at the time the spark is ignited over the compressed air fuel mixture and power is generated. That power, that expansion of gases acts on this cam, pushing the cam in this direction. So once the cam is rotated here, again the volume increases and all the gases, burnt gases are going out. Same cycle repeats here. This is the Wankel rotary engine. You can see the operation of the Wankel engine in this animation. Entry of fresh gas, compression, spark, power, then exhaust. These are the parts of the Wankel engine. This is called a turbofan engine, which are being used in the aeroplanes. This is a very vast subject, which is not required now. Okay, just for the knowledge sake, I am sharing these pictures. The cut section of the turbofan engine looks like this. Please go through these 4 pages notes. In case you have any queries, please get in touch with me through the email. Please do subscribe and ask your friends also to subscribe to my channel.